Hello everyone. In this video, I will be solving the physics improvement exam question paper of the improvement exam. So the first question is an MCQ type problem. The question is, which of the following is a fundamental force which binds the protons and neutrons in a nucleus? The answer is simple. It is a strong nuclear force. The next question is, what is the slope of a position time graph of uniform motion? So we can draw the axis. So for uniform motion, we know that the position will be changing at a regular interval. So the plot will be like that. So the slope of this graph is the velocity. We know that velocity is equal to the rate of change of position. Hence the slope of the graph is the velocity. Hence the answer is option B. Third question, when a bus suddenly stops, passengers tends to fall forward. So this is due to inertia of rest. Sorry, it is due to inertia of motion. Answer is inertia. So the fourth question, let me erase this. So the fourth question is, for small deformations, the stress and strain are proportional to each other. This is a statement of, it's the Hooke's law. Stress is proportional to strain. So the answer is Hooke's law. The fifth question is, in pure rotation, every particle of a body has the same angular velocity at any instant. Check whether the statement is true or false. So in pure rotation, we know that if a body is rotating at an angular velocity omega, then all the particles in that body will be rotating at a constant angular velocity omega. So the statement is true. But their linear velocity may not be the same, because as the radial distance increases, linear velocity also increases. But the angular velocity will remain constant in a pure rotational motion. So the answer is true. Now, so the next question is a match the following type question. So 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 what is a light year? Light year is the distance traveled by light in 1 year with a velocity of 300 raised to 8. And angstrom, 1 angstrom is equal to 10 raised to minus 10 meter. And 1 Fermi is 10 to the power minus 15 meters. And what is an astronomical unit? It is the average distance between Sun and the Earth. Actually, from the center of the Sun to the Earth. So that's the astronomical unit. So we have we can erase this option. It's the wrong option. Okay, so that's the answer of the match the following type question. Now let me erase this. Okay. So the seventh question is, using Newton's second law of motion, derive the equation F is equal to ma. So this is straightforward derivation. You can easily do this. So what is Newton's second law? Newton's second law is F is equal to rate of change of linear momentum, right? Yeah. So what is the definition of momentum? Momentum is the product of mass and velocity. If the mass of the system is constant, then we can take the mass out of this derivative and we have m dv by dt. Now the dv by dt is nothing but the acceleration of the body. So it's straightforward now that F is equal to ma, right? So hence we derive the equation F is equal to ma from the Newton's second law of motion. Now the eighth question. Two bodies of mass m1 and m2 have the same linear momentum. What is the ratio of their kinetic energies? Okay, that's a good question. So what is the kinetic energy? So kinetic energy is the energy of a body when it moves. Okay, when a body moves, then it has kinetic energy. Okay, so we know the equation of kinetic energy in terms of linear momentum, right? So we can write kinetic energy in this equation. Now look at here. Here two masses m1 and m2 both have the same linear momentum. So here momentum p is constant. So only thing that is changing is the mass. And from this expression, it is clear that kinetic energy is inversely proportional to the mass. And if we have m1 and m2, so here question is, what is the ratio of kinetic energy? So we can write as k1 by k2 is equal to, it is the inverse. So we can write m2 by m1. Just write the kinetic energy of two masses and take the ratio. We'll get k1 by k2 is equal to m2 by m1. So that's the answer. Thank you. So thank you so much. I am ending this recording.